All right, welcome to 5-3, adding and subtracting rational expressions without a common denominator. So we have before dealt with adding with a common denominator. Today gets a little bit more complicated. Let's real quickly review what we know. We need to be able to factor these things eventually. Where that happens, we'll talk about in a moment. Greatest common factor, that's what we're always looking for, but most often when we have two terms. Difference of squares, must be subtracting, both terms must be perfect squares. And box and diamond when I have three terms. If you're needing more guidance on that, go back to the 5-1 video. We have also, in the last section, we multiplied rational expressions. When we multiply rational expressions, we want to factor first. So I have it on the wrong function. There we go. Factor first. Then we combine everything and simplify what we can. When we add or subtract rational expressions, we need to have a common denominator. That was the case last section in 5-2. It's not going to be in 5-3. And then you add or subtract the numerators and the denominator stays the same. And then you factor. So you don't factor until you combine everything. So I'm going to say factor last, even though after we factor the top and the bottom, we simplify. But remember that difference, or actually write down that difference. With multiplying rational expressions, we factor first. Add or subtracting rational expressions, we factor last. So this is really just me going over the investigation that we talked about, that we did in class. We know that fractions can't be added or subtracted unless they have a common denominator. If they don't, we can find a common denominator, and that can happen a number of ways. So if I have 3/5 plus 7/2, those denominators are not the same. LCM, what I'm looking for there, what that's called is the least common multiple. So we've been dealing with factors quite a lot. Those are things that multiply together to give us something else. When we're dealing with multiples, we are trying to figure out what those numbers go into. So if I have all my factors of 12, I've got 1 and 12, 2 and 6, 3 and 4. Those are all factors. So a multiple of 2 and 6 would be 12. A multiple of 3 and 4 would be 12. So that's the number that they go into. If I'm looking at the least common multiple with 3 and 4, the least common multiple is going to be 12. That's the smallest number that both of those can go into. If I'm looking at 2 and 6, the smallest number that both of those can go into is 6. So you really just need a common multiple, but the least common multiple will keep you from having to reduce as much. So one of the methods that will pretty well always work is taking the denominator. Oh my goodness, I'll get this on the right function one of these days. Is taking the denominator of 1 and multiplying the top and the bottom by that denominator. So this is what that's about right there. The reason we're able to do that is because we're just multiplying it by 1. It doesn't change its value. Then I take the denominator of the other and multiply it by the other fraction. Again, multiplying it by 1, that's that step right there. Once we do that, 2 times 3 gives us 6. 7 times 5 gives us 35. And of course, that 2 times 5 and 2 times 5 gives me 10. So that's there. When we actually add them, all we're adding, because we have a common denominator, is the tops. So 6 plus 35 gives us 41. The bottom just stays 10 from here. Well, because it's the 10, sorry. Because it's 10 on those first two, it just stays 10 here and here. 41 over 10 cannot be reduced. It doesn't have a common factor other than 1. So that's our answer, 41 over 10. Don't worry about improper fractions. They're not a problem. They're perfectly fine. I would take a moment and practice with these if I were you. So looking at 3 and 12, one of my options is just to multiply both of them by each other. Or I can note that 3 goes into 12, so I don't need to change 5/12. I can just multiply the first fraction by 4 over 4. So that will give me 8 over 12, because I just multiply the 4 and 2 and the 4 and 3. So 8 over 12 plus 5 over 12 gives me 13 over 12. 6 and 15, again, I can multiply those and get a common denominator of 90. That's fine. Or I can note that they both actually go into 30 as well. So multiply the first one over by 5 over 5 and the second one by 2 over 2. So 35 over 30 minus 8 over 30. 35 minus 8 is 27 over 30. 27 and 30 are both divisible by 3, so I can reduce that down to 9 over 10. 7 and 9 is one of those that doesn't have any other options except for multiplying each other. So I'm going to take, or by each other, so I'm going to take that 7, multiply one fraction by 7 over 7, and then take the other one, 9, multiply the first fraction by 9 over 9. So I'm going to have 27 over 63 plus 28 over 63, which is going to give me 55 over 63. And no common factors come to my brain on that one. So that's just when we're dealing with numbers. Now we're dealing with rational expressions. I'm looking at 4x squared and 8x. So I can multiply them by each other to make a common denominator of 32x to the third. I could do that. I'm not going to in this particular case. I'm going to look at the 4 and the 8. My least common multiple there is 8. Is 8. And then I look at the x and the x squared, and my least common multiple there is x squared, because I could multiply x by itself to get x squared. So when I look at this, I need to figure out, when I look at the first fraction, I need to figure out, and I'm going to put parentheses around this for a couple of reasons. I'll talk about it in a minute. What I need to multiply 4x squared by to get 8x squared, and that's going to be by 2. If I do the top by 2 or bottom by 2, I need to do the top by 2. And I'm going to distribute that 2, so I have 4x plus 2 over 8x squared. And then I'm going to deal with the other one. Pardon me. To get from 8x to 8x squared, I'm going to multiply both the top and the bottom by x. Again, I'm going to put parentheses here because I'm going to need to remember to distribute. So I'm going to do x times x, which is x squared, x times 3, which is 3x, over 8x squared. Then I'm going to get it down to one fraction. Whoop. So next up, we're going to be dealing with an uncommon denominator that has no common multiples, so except for multiplying them together. So when I look at x minus 1 and x plus 3, I've got x minus 1. I'm going to multiply the first fraction by x minus 1 over x minus 1. I have x plus 3, so I'm going to take the second fraction and multiply it by x plus 3 over x plus 3. So the most important thing here is remembering that you need to distribute things. So I'm going to take this negative 4, distribute it to the x, so negative 4x, and negative 4 times negative 1 is positive 4. Leave the bottom as x minus 1 times x plus 3 plus, and then I'm going to distribute this 2x, so 2x squared, and 6x. And x minus 1 times x plus 3. Now, I can just combine those two to be 1. I'm going to combine my like terms in this step. My only like terms are 6x and negative 4x. So I'm going to write the 2x squared first because it doesn't combine with anything on top. Then I'm going to write 2x to combine those two, and then plus 4. I'm going to write that as 1 fraction over x minus 1 times x plus 3. Then I want to factor the top if I can. There is a greatest common factor of 2, so I'm going to take that out. X squared plus x plus 2 over x minus 1 times x minus 3 plus 3, sorry. So now I have x squared plus x plus 2 if I want to see if I can factor that. My factors of 2 are 1 and 2, and they're both going to be positive because both of these terms are positive. So the only thing those can add up to are 3, and that's definitely not 1x. So that one can't factor any further, so we're done with that one. So now, again, I would try this one on your own, but I'm going to go ahead and dive right in. I have x plus 4 and I have x minus 4. These are not the same denominator no matter how much they look like each other and how much we want them to be each other. So we're going to multiply the first fraction by x minus 4 over x minus 4. And we're going to multiply the second fraction by x plus 4 over x plus 4. I guess we're technically, there we go. So then I need to distribute x times x, x squared minus 4x, and then distribute that 3, so 3x plus 12, a little out of order, but we won't worry too much about it, over x minus 4 times x plus 4. There's some steps in here that you can eventually start to skip once you figure it out. People are really tempted to start to factor the top and then cancel stuff out. You can't do that yet because that just takes you back to where you started. You're doing all this basically to get that common denominator, but to do that you have to kind of take things out of factored form for the top so you can combine them. I guess I didn't say that very well, but anyway, so now we can go ahead and combine these. So x squared minus 4x. This is what I was talking about earlier. This is minus, so I'm going to go ahead and write this as minus and then put parentheses around that 3x plus 12. And then that's all going to be over x minus 4 times x plus 4. Simplify further. I'm going to have x squared minus 4 minus 3x and then minus 12. I need to take that negative or negative 1 and distribute it into 3x plus 12. So rather than write the bottom again, I'm going to bring this up here. So combining my like terms, I have x squared minus 7x minus 12. And on the bottom, I have x minus 4 times x plus 4. So then my factors of 12, I'm factoring the top right now, 1 and 12, 2 and 6, 3 and 4. One of them is going to be negative. So why do I feel like that was supposed to come out differently? Minus 3 and minus 12. Nope, I guess we're good. Anyway, so for 12 to be negative, 1 would have to be negative. One of them, one factor would have to be negative. Because 7x is negative, it would be the larger number. And unfortunately, none of those adds up to negative 7x. So this one is done just as it is. All right, so sometimes when we're looking at more complicated ones, the bottom will have to be factored before we can figure out what its factors are. So x squared plus 5x plus 6 is going to give me x. I'm going to factor that out to x plus 3 times x plus 2. Those two, 3 and 2, multiply to give me 6, add together to give me 5. So what that means is I need to multiply 2x over x plus 2. So if this is the equivalent here, sorry. This is the equivalent here. There's already a factor of x plus 2 for 2x over x plus 2. What I'm lacking is the x plus 3. So if I want to have that greatest common factor, I also have to multiply the top by it. So I'm going to leave the first one as just 4 over x plus 3 times x plus 2 plus, and then 2x squared plus 6x over x plus 3 times x plus 2. Combine those to give me 2x squared plus 6x plus 4 on the top, and x plus 3 times x plus 2 on the bottom. I'm going to factor out a greatest common factor of 2 again on the top, so I've got 2 times x squared plus 3x plus 2. That one does factor. And that factors to, I'm going to keep that 2 out there, x plus 1 times x plus 2, almost done, over x plus 3 times x plus 2. I do have a factor that divides out on that one. X plus 2 over x plus 2 can go away. So I'm going to factor and cancel at the end on these. So my final answer is going to be 2 times x plus 1 over x plus 3. And that is it for adding without a common denominator. Keep in mind this is the highly proficient version for adding and subtracting, rational expressions. So focus on 5.1 and 5.2 if you're struggling at all. Okay, have a good night.